Hi, everyone. I'm Nicole Moldovan from Lymba, the premier NLP company for working with graphs. Today, I'm going to walk you through how you can get unstructured data from various documents into a usable format in a graph, and then how we can query the graph with plain English questions to get meaningful answers. So here we have a patient complaint as well as her medical history. And we see that we have the issue that brought her in today, that she came in with swelling of tongue and difficulty breathing and swallowing. And we have her history, including all of the medications and devices that she's taken. And it's a pretty comprehensive amount of information. We also have, to help us figure out what could be wrong with her today, information from the clinical trials of some of the drugs and devices that we've taken. And we could see that this document is in a semi-structured format with some tabular information. It also has a lot of information in both longer text as well as some shorter snippets of data points. So NL2Query is UI agnostic. I'm going to show it today in a simple question answer search bar type of interface, but this could be plugged into a chatbot, a medical diagnostic system, or any other application sitting on top of the graph. What's important to think about when we're running things through NL2Query is that we're going to be asking questions from a source of different documents. And we're going to be asking them in plain English or natural language, and then letting the application turn that into SPARQL, the querying language of our graph. So let's start with a simple question. And this is going to be one with the answer from just the patient history. And we'll start with, what is Jane Doe prescribed and with what dosages? So we see here, we get the answer back, and this is reflecting the fields as they were in the graph. And Jane Doe was prescribed Altis, and specifically in 10 milligrams. The SPARQL query behind the scenes is going to be converting that question and then looking for the best answer in the graph. To take a look at that from an annotated perspective, again, it looks very much like our source documents once we've run them through the pipeline. We have our patient, Jane Doe. The patient is prescribed that prescription. So we have prescription as a class, and then we have instances of the class. And we have dosage, which is another class. The _G denotes that it is the class. So again, all of these rules are coming into play again, as well as the ontology. Now, that was kind of a simple question that just had an answer from the patient history, but what if we want to ask something a little bit more complicated? Let's go ahead and ask, what serious adverse events were reported across all of our clinical trials, and how many subjects were affected? So in this one, you'll see that we're now asking questions from an aggregation of the clinical trials. And again, we're seeing the information from the source and what that would look like if I wanted to click on the specific source document. It's going to bring me back specifically to that clinicaltrials.gov. Now, if you're doing this in some sort of business application that is within your own system, maybe you want to tag a specific section of the document, and you can really play around a lot with that UI. It's nice for you to go back to the source. You can also go back and see how that question appeared in the, where that data appeared in your annotated document. But this is again combining from all of the different clinical trials, what the events were and the number of people. So we know if this is anything we have to be concerned about. That is going to look, again, very similarly, where we have the serious adverse event. Again, the relationship. So we know adverse events have number of subjects affected, and it's across all of our clinical trials. Now, another thing that we might want to ask as we go along is something that combines the information across the clinical trial as well as the patient history. So maybe I found now the clinical trials that are focused on the conditions that Jane is experiencing. And I want to ask something that is really pulling this all in together. So here, when I ask these questions, one thing to note is that now we're starting to combine and make those hops in the graph between disparate data sources. So we're getting the conditions that Jane is experiencing, and then we're searching for those conditions in the graph to narrow down which of the clinical trials are going to be relevant. These SPARQL queries start to look a little more complicated. But in general, we like to see that these all come back from the graph, right? We have patient is experiencing, those trials have a focus. There are specific pieces of information here that represented in the SPARQL query look the same when they are in the annotation. Right? Again, we have the clinical trials focused on the condition that Jane Doe is experiencing and the rule and relations that brings them all together. Now, maybe I want to find out if not just there were adverse events, but is this something I'm really going to be concerned about as the healthcare professional? I might want to ask something like how many subjects were affected by these adverse events, reported on medications with the same dosages as Jane Doe, because again, we want to make sure that this is the 10 milligram dosage of our patient. So we're extracting here our patient name, our dosage amount of the prescription, and specifically the serious adverse event. Now, just think about the complexity of this query and why this is really interesting that we're doing this all automatically. The number of factors that would need to be considered, multiplied by the number of documents that you would need to look through, would never be feasible to look at in a clinical setting with a quick search type of question like this. We're looking at information from the history of present illness to find those adverse events and tying them back to multiple clinical trial documents. So here, the ER doctor sees that Jane's been taking her 10 milligrams of ramipril or Altis for hypertension. And there are indeed related to current symptoms, swelling and pulmonary embolism. And these counts are there, but they might be a little bit too low to ultimately show that there's any real cause behind this. The ER doctor then, with his or her medical opinion, can consider the likelihood of Jane's current symptoms being caused by ramipril. Some other things to note here that are interesting. We're not trying to make any medical calls, but these sentences across documents, including this last one here, are coming from a variety of semi-structured and unstructured data. They're coming from a similar governing body or the same governing body, and they're a great example of how we take for granted all of the calculations our mind do in the background to make sense of natural language. If you were to dump these files into SharePoint or try to do a keyword search, even force it into a relational database format, it'd be very difficult to make these connections between the data in a meaningful way. It would also be far less flexible if you then wanted to change how you represented the data. Maybe you overfit initially to cover only drugs, and now you want to expand it to medical devices. So the NLP pipeline takes all of this into account to break down these documents, starting at that pre-processing to the tokenization, entities, and finally semantic relations. When we now add these relations on top of relations, the medications with the dosage from Jane Doe plus the clinical trial information, that's when we really start to see that value and create that semantic web that we've been talking about this week. So that's what I wanted to show you today. And of course, it's a snapshot from an immense amount of documents. Jane is 77 years old. She's been alive for a long time. She has a lot of conditions, medications, devices, and those all interact with one another. The data on how these treatments affected other people can be buried through different documents and stored disparately, which makes it quite complicated. But by using NLP with your graph and letting the pipeline do a lot of that work for you, you can hopefully make it less complicated and get more out of your data. Thanks for watching from Lymba. Please reach out to us with any questions or for help on your next project. To receive a free consultation, email us at info@lymba.com, where we can customize a demo to suit your needs about your specific situation.